Okay. Hello, everyone. Can you hear me? You cannot hear me? Oh, yeah. Okay. Thank you. So this is Econ325. So I'm going to be teaching this class. My name is Hiro Kasahara. I've been teaching this course for a while. I don't know how many years, like 5 years or 6 years. So over time, I developed the course material. And I'm now comfortable with content I'm teaching. So, but it's not necessarily an easy course if if you haven't taken any probability or statistics course. So you have to work hard. But if you work hard, then you should be able to just do fine. Okay. By the way, if you do have any questions, either raise your hand or unmute yourself and ask me questions. Asking questions is especially important this year because it's online teaching. And if nobody asks question, everybody get bored and loses focus and everybody lose. So asking question is really, really encouraged. Okay, so I really appreciate if you ask questions. I think there is, okay, so there's a chat. Um, and then there is like a raise hand button, which I never understood myself how the students can do it, but everybody seems to be able to do that. So you can either raise your hand or sometimes I might not see everybody. So if I don't recognize when you raise your hand, you just unmute yourself and start asking questions. Okay. Due to the current situation where some students taking this course, not necessarily in North America, some students are in China and the other students are somewhere else in the world. So due to the time differences, some students cannot participate in live Zoom meetings. So all the classes will be recorded and posted on Canvas. So if you are not able to attend the class, make sure you actually view the video recording because there will be a clicker questions. Usually on in-person meeting, we usually have a clicker question, but this year we cannot. So instead of doing a live clicker question, I ask you guys to complete clicker question online as a quizzes, okay? So make sure if you're not participating in live Zoom meeting, you gonna watch the video just after on the same day we have teaching, and then the complete quizzes. And then those who participate on live now, you also should have to do a quizzes. We have a one TA, Silas. He is going to have also lab sessions, which mostly cover the assignment questions, especially the difficult ones. So I highly recommend you to participate in his lab session, which is Monday from 5 to 6 p.m. I also have office hours on Tuesday from Tuesday. Did I say Tuesday? Actually, this is typo. It is, okay. So there is a mistake here. I think it's the Thursday. Sorry about this. Thursday from 5 to 6, so it's actually today from 5 to 6. So if you are participating from other country, and then if you do have a question so that you cannot ask online, but if you watch the video and if you have a question, once a week you have a time to ask me questions, okay? And also that if you have a question on the assignment and other thing, ask question on the discussion section of the Canvas page. Okay. Okay. So textbook and the references. So we do have a one textbook, Newbold, Carson, Thorne. This is a textbook which I have used, but over time I developed my own class notes and then lecture slides that are posted on Canvas, especially the first half until the midterm. You might not necessarily look into the textbook. You can rely on the class notes I've written. The latter half, probably you like to refer to other textbook, including the main textbook I pick, which is the new edition tend to be expensive, but if you can take older editions, any editions are fine. The content of the statistics and the probability we cover in the class hasn't changed over the last 20 years or so. So any older edition, which you probably purchase at a very, very reasonable price if you search for over the internet. You don't necessarily need to get the newest edition. Okay, and then I picked also the other references, including the free textbook online introductory statistics. So you can also use those textbooks. The Hogg, Tanis, and Zimmerman. Okay, so this textbook, the last one is very good textbook if you are mathematically oriented. Okay, if I teach the more upper level students who have a better mathematical background, this is the one I'm gonna pick. So if you're really mathematically oriented students, you might actually skip the main textbook, rather look at this textbook. Okay. You had a better, you gain more knowledge out of it. Okay. Grading, important part. So usually I put more weights on the final, but this year is again the special year. I'm gonna put more equal weight across different materials we cover. So midterm exam, 35%, final exam, 35%. Quizzes, this is just a clicker question on lecture video. So you, along the way, I have a slides, and then the slides has some clicker questions, but I cannot do the clicker. So you do online quizzes later after the classes probably. But if you have access to Canvas, you can also do quizzes on Canvas at the same time. That's possible. And then the assignment, there will be 8 assignments, and that will give 25% of the grading, okay? Midterm dates has been determined. It's gonna be from 5 to 6:30 p.m. on Thursday, October 15th, okay? We're not gonna have regular classes on the midterm date, but I probably gonna have office hour. Okay, there's no makeup exam because it's very, very difficult to have the similar difficulty of the exams for midterm. So if you miss it for whatever the reason, you have to have a legitimate reason to miss, and then you have to fill in the concession form, which I'm going to talk about later. But if you miss it, your midterm weight will be shifted to your final exam, okay? And also I have to be explicit here. Some students after taking a midterm exam, because they didn't do good, well in the midterm exam, some students ask shifting the weights from midterm to final. But once you take midterm exam, there is no way I'm gonna allow you to shift the weights from midterm exam to final exam simply because you didn't do well as well as you expected. Final exam is gonna cover all materials up to the midterm, and then I'll be explicit about the definitely there will be some question coming out of the material before the midterm exam. So final exam covers all materials, although that relative weights are going to be toward the material we cover after the midterm. So here quizzes. So there will be again review questions during the lecture, which is the clicker questions. So you have to complete quizzes on Canvas after live Zoom or watching the lecture video. That's going to be a 5%. Assignment, there will be 8 assignments. So there's many assignments. For each assignment, because there are 75 students and the 8 assignments, it's very difficult for one TA to grade everything. So the TA is going to pick randomly some question to be graded for each assignment. Okay. There is a one, so the grading wise, so there's 8 assignments, but the worst assignment grade will be dropped for grading. So potentially you can miss up to 1 assignment to get the perfect score for the assignment grade. Okay. This is because sometimes you have some medical reason you cannot finish assignment on time, or sometimes you're too busy to complete assignment because that the other assignments, other courses you take require to spend more time on it. So that you can you can have an option of dropping one assignment. But I strongly recommend to complete all the assignments because simply because you're going to be behind if you don't do so. Okay, and then that will reflect if you spend the time on completing assignment. If you miss one assignment and don't spend time on it, then you're going to suffer when you take a midterm exam or final exam. No assignment will be accepted after the lecture. Actually, it's not going to be the lecture on the due date, but actually the midnight on the same date of the lecture. I typically put the due date on either Tuesday or Thursday, and then typically the due date is going to be midnight. Okay. You have to submit by yourself. So in other years, I allow to have a group, study group, to study together and submit on behalf of the study group. But this year, it's hard to do study group and submit as a group. So this year you have to write yourself and then submit. Online study group is encouraged, but you have to write your own answer. Okay. And then don't copy somebody else, because if you do so, if they're two identical, words by words, identical answer, the TA will notice, and then we might have to have a Zoom meeting together to see whether you have enough understanding on the assignment or not, just to make sure that you're not just copying your friend's answer, okay? And the same for that, so that I realize that sometimes you can look for the answer key over the internet. If you copy and paste, that's going to be immediately clear, because that there's a really line by line copy and paste. You can easily tell. In that case, again, we're going to have a Zoom meeting. Okay, so just don't copy and paste the answer you find over the internet. Sometimes that we know that internet answer key in the past, there's some mistake, and then if you do the same mistake, we can easily tell. Okay, so don't do it. If we find out, then you might be in trouble. Okay. Okay, so there's also the UBC white policy statement about academic honesty and so on, and you have to follow that. Let me do one more thing. Okay, I'm not here. syllabus. Okay. Here. Okay, so if you miss assignment for legitimate reason, or if you miss midterm for legitimate reason, you have to complete a concession form by going to these sites. So arts students must conduct arts advising when there is an interim concession, okay? In terms of topic, we're gonna cover the describing data probability and so on. You can, all the slides have been uploaded on Canvas, although that along the way, I will update those slides as it goes. But you can quickly look at those slides to get a sense what types of material we are going to cover, okay? Another thing I wanna talk about is Canvas. Could I go to Canvas? Plus, where is it? Canvas, I should have Canvas somewhere. I don't have it. So let me actually go to my. Okay, there we go. So let me switch my screen to share on desktop. Okay, so if you go to Canvas, or let me make it the student view. Okay, so this is when you enter the course web page on Canvas, you see this, okay? Important thing is going to be academic misconduct here, okay? In order to access to other course materials, I think I set up the way so that you have to complete academic misconduct quizzes, okay? So this is something you have to do first. If you don't do it, I'm gonna chase you down by sending you email to complete, okay? And then all the course materials are gonna be here, okay? And then if you go to quizzes tab, and then, so there's academic misconduct you have to do. This is the first thing you have to do. But also, there is clicker questions, okay? This is only the first slides I posted, but so there will be like multiple choices. I hope this is set up right. If you think there's something wrong, then please do let me know. But so if you go to this clicker question, there is a multiple choice you have to complete, and please do so after finishing the lecture or watching the lecture recorded video. Okay. Back. Okay, so far no question. Everything is clear. Where am I going? Okay. Okay, you don't have any questions. Do you see an introduction slides, right? Okay. If you don't have any question about anything, I'm gonna just keep going with example. Is a quiz starting next week? Oh, okay. There's a very, very important question on the chat. Somehow I haven't seen any of the chat. So if you do have a question, you don't necessarily need to do chat. You just ask me. But okay, so there's a few questions I received on chat. Quizzes, you can start doing it as it goes, because at the some of the quizzes on clicker question, you can finish today after the lecture, but depends on the how far we go, but I expect I might be able to finish all, okay? There's like a lab on Tuesday. Okay, so it's not the Tuesday, so that my office hour is Thursday. I think the class TA's lab session is Monday. If I'm wrong, let me know. I think oh, actually Tuesday? I think it said Monday, so I think the TA session is Monday. How many days do we get complete assignments? So usually you're gonna have weekly, maybe 10 days between assignments. So that's a time frame. Is there any course outline that states when our assignments are due? Okay, so if you have that, that's I think an important question. So let me actually go back to where it goes. Oh yeah, here. To the Canvas. If you go to assignments. Okay, so if you go to assignments, right. Already the due date has, all the assignments has been posted, and then all the due date has been posted too. So typically the due date of assignment is gonna be either Tuesday or Thursday at midnight, okay? So you know the schedule if you go to the assignments. Okay, there might be other question I missed. Do you recommend taking notes on paper or what? Oh, okay, so this is very important. When you watch the video, you have to have a pen, pencil, and the paper or notes. So you write. If you have a tablet, like iPad or other Android tablets, which you can write on, that's fine. But just watching the lecture without having any pencil or pen, I don't think that's a good idea. You keep writing as you go, because that's the best way to learn mathematically oriented material like this course, what we're gonna cover in this course, okay? So make sure you have a pen or pencil, okay? You can write on the tablet, that's fine. And then you can also, of course, complete your assignment with tablet, okay? And that's easier, okay? So that makes sure, but typing is not recommended. Actually, yeah, I think that I'm gonna cover at some point that there is some randomized control trial evidence that tablet, writing on tablet, sorry, the typing might distract you from understanding. So that for mathematically oriented course like this, you should definitely take the pen or pencil and write on the paper when you take a lecture. I am registering a Tuesday lab. I am not sure how the multiple lab session appears. So I'm gonna check later, but it's gonna be a Monday lab that you should register. Or it's a registration of the lab itself doesn't matter, but make sure you're gonna attend the Monday lab session, because it's nothing to do with grading. Even if you register with different lab, it doesn't matter. But course materials is a session specific or section specific, so that you should definitely attend the Monday TA session. Okay. All right. Any other questions? Nobody has spoke. So those in the lab have to attend the labs, Monday lab as well. No, you don't need to attend the Tuesday lab. You only need to Monday lab session, okay? Okay, you have a class during the Monday lab, so that's the problem. Yeah, I mean, there's nothing, not much we can do. You can, but it's gonna be recorded, so you can watch the video afterwards, okay? So the Monday lab session is gonna be also recorded, so the TA is gonna cover the assignment question, often the difficult ones, so that you can watch the video later. So midterm exam, there is other class and so on, then we had to talk. Probably what we're gonna do is as soon as you finish class, you're gonna start writing the exam, okay? So that there could be a little bit of the timing difference in taking exam, but there's not much of time gap. There is no Tuesday labs. Okay, there's only one lab, okay, Monday, 5 to 6. Okay, but if you have a further question even after the today's lecture, I think the best way is just put in a discussion. So if you go to, okay, stop sharing the screen. Here. So there's a discussion. Assignment questions or any question regarding the classes you want to ask here. Sometimes I receive the email and then just copy and paste it here, but it's going to save me a time if you put it here, so that if it's an important question, then I like to have a discussion here. Okay. So the reason why there's a multiple labs is that there are multiple sections of 325. And then as I understand that each lab, TA lab session is attached to the specific sections, okay? And then somehow the students are allowed to take the labs that it belongs to the different section. I don't know how things go, but that's my understanding. Okay, let's move on to the actual content of the class, okay? So today we're gonna cover some example to motivate what we're gonna learn in this course, okay? So, so introduction. So we're gonna talk about probability and the statistics, but in reality, what we're gonna do is that we gather the data and then try to understand what's going on in reality. And then that will help us to make decisions, okay? So one of the example, hopefully I have a chance to talk to is like COVID-19. And there's something we don't know when the COVID-19 started. And then we try to gather the data and try to understand what's going on. And then based on that data we gather, we're gonna make a decision, okay? But when we're trying to understand what we gather as a data, we really have to understand that there's a randomness behind, and then so the probability, the concept of the probability is gonna become very, very important, okay? And the probability and statistic provide a tool to help process, summarize, analyze, and interpret data. Okay, so today we're going to cover a few examples. So actually there will be more than 5 examples. So I have to, this is again typo. I have to, because I increased the example 1, 2, 3, 4, 5, 6, 7. 7 examples. I'm not sure how many examples I can cover today. Okay. So I'm gonna just talk about some example. All right. So the first thing is about homework assignments somehow. Okay. You become busy during the semester, and then you have to make a decision of whether you're gonna complete homework assignments or not. Okay. To make that decision, you like to know this fact. Okay. So this is a so-called scatter plot. Okay. Based on the past students' data who took this course 325. Okay. So what this does is I am going to look at, so each dot represents a student who got certain homework grades and the final grades. Okay, and then there is a straight line that is try to mimic the relationship between homework grades and the final grade, final course grades. As you see, those who did bad in homework, okay, so there are some students, so say suppose you're gonna look at like a middle point of the 6 as, so it's a 10 out of 6 homework grades, okay? So someone who got the less than 6 tend to have low final grades, okay? And many of students work hard. And then there are some students who, even if they did very good with homework close to 10, but still get the low final grades. But most of the students who did very good job in completing homework tend to do a very good job. Okay. So in fact, if you define the low homework group as students with homework grade less than 6 out of 10, and then the high homework group as someone who got higher than 6. So suppose I'm gonna divide the students into 2 groups, low, high, okay? And then look at what's the distribution of the final grades. That's very informative about how well they're gonna do in terms of the passing the course. Okay, so this is, the left panel is gonna be a low homework group, someone who got less than 60% in terms of the homework assignment grades, okay? So there, this is the empirical distribution of the final course grade. Someone who received less than 60% of homework is gonna be, most of them, majority of them, gonna get less than 60% of the homework assignment, and then more than half is gonna fail the course, okay? So if you plan not to complete the homework more than half of the time, you might as well wanna drop this course because you're gonna fail, okay? And then if you look at the high homework group who received more than 60% of homework grade out of 100%, they tend to do well, relatively speaking, to the low homework group. Although, of course, even if you do well in the homework, it doesn't guarantee that you're gonna get a very, very good grade. But definitely, you tend to get much better grade if you do homework, okay? So hopefully this data gives extra information about this course, how important completing homework assignments are. So homework assignments tend to be give low weights, it's only 25%. Actually, the usual case, you only get the 20%. So that this year is going to be more important than the usual year to complete the assignment, because there is a direct effect on the final grade with the higher weights on the assignment. But the indirect effect of not completing homework is even more important, because if you don't complete homework, you tend to do very bad in the midterm and the final. Okay. Oh, I have another question about the lab. Okay, so there appears to be like 2 lab names. It actually doesn't matter which lab you register. It nothing to do with grading for the course. So it doesn't matter. Okay. So as long as you do, yeah, you can even register with the different days of week. What's important is going to be that you have to look at the, yeah, you check the course web and look at the, you either attend the Monday lab live, or you watch the recorded video, which is going to be posted on Canvas course web page. Okay, so if you look at actually the left-hand side graph, split in the middle, turns out more than half of students in low homework group failed Econ325. So make sure you work on the homework assignments. Again, online study group is very much encouraged, okay? Don't copy and paste, but discuss about how to solve the homework questions and so on is very much encouraged. We may actually test the hypothesis based on this data set. Okay, so hypothesis testing is something we're gonna spend a lot of time on in this course. Okay, so you're gonna make up the hypothesis, which you sort of hope to reject. By rejecting, you are concluding that hypothesis is wrong. Okay, so in this case, you're gonna set up the hypothesis that the average grade of high homework group is the same as that of low homework group, okay? And then if you reject this hypothesis, then you indirectly supporting the alternative hypothesis that the high homework group do better than the low homework group in terms of final grade, okay? And then this is how to do it is something we're going to learn in the latter half of this course. Okay, another example is A/B testing. So A/B testing is very, A/B testing is a very basic tool that all internet companies are doing when they construct a website. So here's the essential idea, okay? So when a web designer choose particular color or web design, they do not know exactly which one is better. So typically, if you think about the Google or any other search engine type site, they are making money by providing an advertisement, okay? And then how they make money is that if someone visit that particular page and they click on the advertisement, that will give the Google the money, okay? So that as a Google, when they think about how and where to put the advertisement, they have to think carefully about how to maximize the click rate. Okay, so the choosing the blue color and the green color, which one gives you a click rate, you actually do not know usually, ex ante. So you come up with two different web design, and the objective of the Google is maximize the click rate. How they're gonna find out? They're gonna do so-called A/B test, which is a version of randomized control trial, okay? So what they do is that they're gonna assign randomly. So if somebody visit the website, a particular address of the web address, then the Google is gonna randomly assign each visitor to two different websites. One website has blue color in terms of this learn more tab. The other side is gonna have a green color. And then they're gonna split half and half. For every visitor, flip the coin. If it's tail, you're gonna get the blue color website. If it's head, you're gonna get the green color website. And then they're gonna do it to everybody, so that if you got like 10,000 visitors every day, you're gonna have approximately 5,000 visitors on the blue color button, and the other 5,000 visitors on the green button website. And then afterwards, they collect the data and then find out the click rate, okay? And then suppose that in this particular case, somehow green button gives you 52% of click rate. Well, actual click rate is much lower, okay? But just as an example, okay? And then among the visitors who visit this green tab website, they get 72% of the click rates, okay? And then here's a question. So, and then usually I ask students to do a clicker, okay? Which of the following is true, okay? So this is a question you have to finish on the quizzes on the Canvas. Okay? Which of the following is true? With certainty, design B has higher click rates than design A. With certainty, design A has higher click rates than design B. There's not enough information to tell how likely design B has higher click rates than A. Okay, so I think there's like, yeah, polling, but I didn't set up the polling. So I don't know how to do polling. Okay, so actually, yeah, I had to. Could I set up this? Yeah, I don't have a good enough knowledge on the polling. So, okay, so I let you do a chat. Okay, so randomly could you guys put A, B, C if you feel like? Okay, so that means everybody is listening to my lecture. Okay, somebody want to debate from everybody else? Okay, so of course, the answer is C. There's not enough information to tell how likely design B has higher click rate, because on these slides, I didn't tell you anything about how many visitors they had, okay? Maybe they only have 100 visitors, or maybe they have 100,000 visitors. So we do not know about the information about how many visitors they have. If they say, 1 million visitors, then close to certainty, we can say design B is better. However, in this case, we don't have information about the sample size. Turns out sample size is very important in terms of to think about the probabilistic nature of the problem here, okay? So A/B testing, no information in this context about how the data is generated. Is it randomly assigned? It's actually, I explained as if it's a randomly assigned, but important point here I try to emphasize is that we don't know how many the sample size is. If it's only 100 visitors, by just some luck, maybe A and B has a same click rates if you got a very, very large number of observation, but if you only have only 100 visitors, then by some luck, that it turns out that maybe that design B has a higher click rate. Okay, so the sample size is important. Now there's one question about what is the smallest sample size required. There's no such a thing as the smallest sample size. The more the sample size is, the more you have in observation, the better, okay? And what do we mean to say better? You only can make probabilistic experiment like with probability more than 90%, design B better than A, okay? So that you never get the certainty, but you can attach the probability about design B is better than design A. And then this probability you can attach depends on the sample size. Okay, that's something we're gonna learn later. Okay, so this is an example I said. Okay, just to make it clear everybody's understanding this. I think everybody seems to understanding this, but just clarify. So suppose you only have 200 visitors. In this case, 52 out of 200 click the design A, 72 out of 100 design B, okay? So randomly assigned, with this data set, if suppose we have this data set, then we can test the following hypothesis. Click rate of design B is the same as that of design A, okay? So note that the way I constructed the hypothesis, I am actually putting the hypothesis that actually equate the click rates of the design B and that of design A, okay? And then we're gonna do the so-called hypothesis testing, which we're gonna learn how to do later, okay? And then if this hypothesis is rejected, then that means that the B in this data, the way it's going to reject it is going to be design B. That means that the design B is better than design A. Okay, providing a statistical evidence that B is better than A. Here we have to be careful about what do you mean by better. Again, we have to attach the probabilistic notion to better, what better means. But that's something you're gonna learn later, okay? Compare that example with the case where you have 200 billion visitors. In this case, almost with certainty, the click rate of design B is higher than that of design A. Again, you can actually make it a bit more precise about what do you mean by almost with certainty. You can attach the probability. And then probability is close to 1, okay, in this case. All right, so that's one simple example, but, okay, actually I had to say something here. So my guess is that some of you become data scientists. I don't know how many of you become data scientists later, or many of you involved statistical analysis in the future because there are many jobs like that, especially among econ major graduate students, okay? And then there are many data scientists who are from computer science background, okay? As a econ major, what you want to contribute to, you're gonna learn how to program if you become data scientists like Python or R and those software. The learning software is one thing, but setting up randomized experiment is a very different thing from the learning the programming. So in this case, it's a very simple setup so that you're just going to randomize the visitor into 2 groups. But it's more complicated context that you really have to think about what do you want to learn about and how to formulate the randomized experiment so that you can actually learn something about population. okay? And that's very important to obtain the knowledge about how to formulate a randomized experiment given some objective, such as knowing which website gives you better, higher click rates. Okay, so this is a very, very simple setup. So you can immediately tell here is a way to do randomized control experiment. But in other contexts, it's not obvious at all. And then especially that there is some concern about endogeneity. And learning those things is very, very important beyond the learning about programming. And that's hopefully you getting some knowledge about completing this course as well as other courses in economics. Okay. Okay, another thing, another example study of lung cancer. So Dole and Hill, 1952, so it's more than, what, 60 years ago? They have published one very influential journal articles interviewing 1,357 men with lung cancer in hospital. So they visited many different hospitals in England and then find the lung cancer and interview them. What do they interview? They interview about how many cigarettes they're gonna consume every day. Okay, and then also, so that's what they did. But the important thing what they did was that they also interviewed another set of 1,357 men. They are in hospital, but without lung cancer. Okay, so they might have a different type of cancer or different types of disease. So that's why they are in the hospitalized. However, they also collected different set of 1,357 men without lung cancer, okay? But they have the same disease, the different disease. And they ask a question also that how many cigarettes they consume per day, okay? It is important to interview not only here the patient with lung cancer, but also the patient without lung cancer, but hospitalized, because they wanted to have so-called control group to compare. And here is their data, okay? So among lung cancer patients, there are 1,357 of them. There are only 7 patients that do not smoke. Okay, in terms of percentage, it is about only 1%. And then almost all of them, I should say, 1,350 out of 1,357 are going to be smoker, was smoker. More than 99% of them are smoker, okay? So this is an old age, about 60 years ago. So everybody smoked, okay? However, if you look at the patient with other disease and hospitalized, but without lung cancer, 61 of them are non-smoker, and then only 1,296 of them are smokers. So substantially less of them are smoker, although overwhelming majority are smoker. If you compare the percentage-wise, the lung cancer patient, 90% is smoker. A patient without lung cancer but other disease, 95%. So it's still, there's a difference in terms of the fraction of the smokers. And then Dole and Hill asked a question and test the hypothesis, following hypothesis. The likelihood of being a smoker is the same between lung cancer patients and the patient with other diseases. So that's the hypothesis they test. And then they rejected statistically the hypothesis, this hypothesis. And then the rejecting this hypothesis gives statistical evidence that smoking is associated with lung cancer. And then this is one of the first paper in the world that provide the statistical evidence on the association of the smoking and the lung cancer. Okay. By the way, you're gonna do the statistical test based on this example after the midterm. Okay, so another example about the blue lights and the suicide. The question is, can blue lights at train station prevent suicide? Well, what is this all about? So this is actually a Japanese example where I'm from. So in Japan, if you visit Tokyo and if you do morning commuting or daily commuting, you often hear the announcement saying that due to some accidents, the Yamanote line, which is one of the major line in Tokyo, is stopped due to some train accidents and so on. And sadly, most of the cases that is because that someone commits suicide by throwing themselves on the train, okay? And that has been a very, very important social issues, okay? For both that how to prevent suicide is important issues, and also that committing suicide by throwing yourself on train is also the economic cost, not only yourself, but also the train stops and the family has to pay out of the cost, pay out of their pockets on economic costs associated with the suicide. So this is very, very important, serious issue on the multi-dementia, okay? And then some train companies, I think it's a JR East, although that is not explicitly mentioned, try to reduce the suicide by installing blue lights, okay? Railway and the metro suicide constitute a major problem in Japan, but because some stations started the blue lights, there's some evidence that the blue lights, having the blue lights at night, reduce the suicide during the evening, okay? And then that Matsubayashi and his co-author, one of them is actually someone I know, working together, examine the effect of blue lights on the number of suicide by using the panel data from 71 train station between 2000 and 2013, and then compare the number of suicides before and after the intervention of blue lights at the 14 station, using other station that never installed the blue lights as a control group, okay? And then they found that the effect of installing blue lamps decreased the number of suicide estimated by at 74%. That is very, very substantial, with 95% confidence interval given by 48 to 87%, okay? The interpretation of those confidence interval is something we're gonna learn. Okay, so this is the one table they provide. Okay, so they actually look at the station with blue lights installed and compare the average number of suicide per year before and after. Apparently, after installing the blue lights, the average number of suicide per year decreased. Okay, as a control group, they look at the next station, the station next to the station that installed the blue lights, and compare the before and after. And there's not much of the differences before and after. in a station next. Okay, so that looks like blue light installation reduce the suicide. Okay. You can formally test the hypothesis testing, do the hypothesis testing again to make this as a statistical evidence. The hypothesis here, again, is going to equate the before and after. Namely, the average number of suicide is the same before and after installing blue LED lamps. Okay. And then they actually reject this hypothesis and conclude that statistically there is association between the blue light installation and the reduction of the suicide. Okay, statistics, understanding statistics and the probability is also important to interpret the blood test you often do when you see a doctor. So if you go to an emergency room, like Vancouver General Hospital, you have to wait, after waiting like 5 hours, first thing they do is that they often do the blood test, okay? And then they do a blood test to get a sense that what might be wrong in your body. So the blood test is everywhere, and if you see the results of the blood test, you often see that some numbers are out of normal range and so on, okay? And then that's a type of the screening test in the sense that a doctor and yourself try to get the information about what's possibly wrong, and then seeking the next stage of the treatment, okay? One example of such a test is a screening test for cancer. So you feel a little sick and then go to a doctor, and then after doing a blood test that suggests the possibility of cancer, you might actually, doctor ordered another screening test for cancer, and then you receive the results. All right, your screening test for cancer said positive. Namely, you might have a cancer. Or you panic because, if you're told that you might have a cancer, of course, everybody panic, right? But you have to be able to understand what exactly this positive means, okay? That's where the understanding statistic behind is important, okay? The typically screening test could be, there's like a notion of the false positive, false negative. Even if you do the COVID test by going to like a COVID testing center in downtown or somewhere else, do a COVID test, and then suppose that you become negative. All right, you're negative and you're very happy, but there might be some possibility of the false negative. Okay, so understanding the possibility of such a thing is very important, okay? Even the context of the COVID test. Here in this example, I'm thinking about the example of the screening test of cancer, okay? And here is so suppose exposed, there's a 10,000 patient with tumor that without tumors, okay? And in this population, in this example, out of 10,000 patients exposed, they have 100 patients have a cancer, and then the rest of 9,900 do not have a cancer, okay? And then these 10,000 patients took the screening test, okay? Some of them received a positive, others had a negative, okay? So if you happen to be one of those 10,000 patients, and then among those, you happen to be receiving a positive test, you are one of these 1,570 patients who received positive, okay? And then again, you receive the positive results, so you are panicked, but you have to understand if this is a data, even among those who received the positive results for screening tests for cancer, overwhelming majority of them have no cancer. Only small portion of them has a cancer. Okay, so the probability of having cancer if the test is positive in this specific example is only 5.4%. So it's very small. Okay, so screening test is designed like this often. Okay, because screening test is very, very cheap and it's not intrusive. In order to find out whether you have a cancer or not, you typically have to do biopsy, which is very, very costly in terms of your health as well as the actual cost. Okay, so that they do a bit more of the screening test to make sure that you have a higher chance of cancer, and then do the next treatment like a biopsy. It's still useful because probability of having cancer if the test is positive is 5.5%, 5.4%. However, here's a quicker question. Suppose your test is negative. How likely do you in fact have cancer? Okay, here you have to have pen to compute, or you can use the your telephone and then go to the calculator and then do what 15 divided by 8,430. Yeah, I got it. Oh, everybody is saying B. Yeah, as long as you can read the digit right, you're gonna get the B. Yes, B is correct answer. So this is a sense to which screen test is actually useful, right? So that it's very rare to have a cancer if your test is negative. So it's very informative. You still miss 0.18% of patients who have a cancer, but this number is much, much smaller than 5.4%, 5.4%. So it's very informative test in that sense. Okay, but again, you learn two things. One, nature of the screening test. You might not necessarily panic about having a positive test. You actually have to somehow try to get this type of data so that you understand better. Okay. Two, even if the probability of having cancer if the test is positive is very low, like 5.4%, still informative. And that's why that doctors use this type of screening test. Okay, we are almost, well, we got, oh, we're not done yet, right? It's around 20 minutes. Yeah, we're gonna have 12 more minutes. So hopefully we can finish these slides today. Okay, the other thing is a mask policy and the COVID-19, which turns out to be my research interest, and I've been working on this topic now. So, mandatory mask policies has been very hotly debated topic and a political topic in some sense, especially in the US. I guess in Canada, it's less so, although still for some people, it's about a matter of freedom. So it's still controversial policy. BC hasn't implemented the mask policy, although that TransLink and other places, including like Walmart and then maybe some grocery store, have at least a mandatory mask policy, at least voluntary mask policies. Okay, and then also I think the BC, the mask wearing rate is higher than some of the southern US states. So what I did as a part of my research is that, so in the you're looking at the 51 US states, some states started the mandatory mask policy earlier than others. Some states never adopted mandatory mask policy. And then we ask a question, after implementing mask policies, the growth rate of cases as well as deaths has declined or not. And then there's a multiple way to analyze this. And especially like you have to do a regression analysis by controlling for other potentially important factors. But the first thing we did was just look at how after the mask policy implemented, between the states that didn't implement and the states that have implemented, how the growth rate of cases changed. Okay, so this is the results. So the vertical line plots the average growth rate of cases among states that have implemented mask for employees. So the blue line is the one that implement the mask policies. The red one is the states that average of the growth rates of the cases among states haven't implemented. Okay. So as you see that the states that have implemented mask tend to have a lower case growth on average about 0.01, I guess, across a period. That means that 10% of less growth rate in the cases weekly. And it turns out that the 10% difference doesn't sound big, but it's a growth rate, and there's an exponential growth factor kicks in. So if you have a difference in the 10% case growths, you're going to have a very, very large difference in the case numbers over the period of like 1 month or 2 months, as we see in some of the US states like Florida. You can do the same thing for the death growth rates. It turns out that the death growth rate is much, much noisier than the case growth rates. But nonetheless, you still see the similar pattern that the states that implement the mask policy tend to have a low death growth rate than other states that never implemented. Yeah, so there's a one interesting question raised on chat that the states that tend to adopt the mask policy is Democratic-led, and then the others are the states that did not implement are Republican-led states. So it turns out that's not the whole story. So even if you look at only Republican states, and then look at the before and after implementation of the mask policy, you have a decline in case growth and death growth, even if it's a Republicans led states. Okay, and but it's true that the Republican led states, especially the states that have a higher voting rates on Trump in the last election, were slow to adopt the mask policy. Okay, but still, that is analysis. We have done this analysis in by the end of May. We have a paper published, not the published, but the preprint, publicly available, and then circulated, and then there are some media articles that covered our study. Like, let's see. So here's a Newsweek article. They cover our papers, and so it turns out that we did counterfactual experiment and so on, and found that we did the experiment in based on the estimated model, and what will happen to the number of deaths if they have all the states adopted mask mandates in April. Actually, we changed now to the mid-March. And then there is our results suggest the tens of thousands of lives would have been saved. So if you're interested in, you can actually look at the other things like as well as paper. Okay, so along the way, I might change the slides as we just did, as I just did for the introduction slides, by incorporating some topic on the COVID-19, as well as US presidential elections. That this is a year, so we can look at also that how Trump versus Biden's doing in terms of the, some survey data before the elections, and to see whether that which one is going to win with what percent and so on. Okay, so those two topics I try to incorporate a little bit at least when as we go. Slide has been updated yet though. Okay, the last 4 minutes. So last 4 minutes, very easy topic. It's been long since Canucks was in have been in the Stanley Cup Finals. And so in 2011, Vancouver Canucks versus Boston Bruins. Well, that was a finals, and there was a riot after that. That was like a bitter memory for me. You guys may not know. So in this Stanley Cup, turns out Canucks did very good in the first two games because they won the first two games. Okay. After having this, many sportscasters are saying, okay, bringing up statistics saying that, all right, some team who got first two games, the probability of winning a Stanley Cup is blah, blah, blah. Okay. Once we learn the very basic probability, we can actually compute what will the probability of Canucks to win if they won to the first two games. Okay, this is something we can do. So when you're watching some games in hockey or basketball and soccer and baseball, you can always compute this type of statistics. Okay, so here's a quicker question. This is actually not an easy one. So you probably cannot do it on paper and pencil now, but you try. Suppose that probability of winning each game was 0.5. Namely, as is usually the case that it's close to 50-50 probability. Suppose that is the case. And then what is the probability that Canucks could have won at least 2 games out of 5 games? Namely, Canucks won 2 games in a row in the first 2 games. There's a 5 game left. If they can win 2 games out of 5 games, they are done, right? So what would be the probability to win 2 games out of 5 games? So that would be the probability that if I were a sportscaster saying that okay, Canucks won 2 games in a row, so here's the probability of winning the Stanley Cup. Yeah, so this is a difficult one. It's a clicker question you have to finish. How are you going to compute? Well, this is actually not an easy one. So let me give you the next slides. All right, turns out you can compute the distribution of probability distribution of how many games you can win out of 5 games if it's a 50-50 chances for each game. So this is an example of binomial distribution, which we're going to learn later, okay? And then as long as you win more than 2 games, you're going to win the Stanley Cup. So the answer turns out to be about 0.81%. Sorry, 81%. So when Canucks won 2 games, first 2 games, everybody thinks that the Canucks will win the Stanley Cup, but that didn't happen because they, against the odd, they lost. They couldn't win 2 games out of 5 games. Okay, I guess this is just right. Okay, we are done. Thanks for listening to my first lecture. We're gonna move on to the, okay, so there's one chat, the individual probability random, so that's the assumption, okay? Of course, there's a dynamics of games and which game is gonna be home and so on, so it's more complicated, but this is as a first approximation, this is a good approximation. All right. Thanks a lot. If you do have a question, you can ask me a question afterwards. I stay 5 minutes or so, but otherwise, this is the end of the lecture today. Thanks a lot. And also, I'm gonna have also from 5 today. Thank you. You can leave if you like.